All right, we will begin our review for the final exam, and this is a practice test that I've made. I'm going to make several small videos rather than one big one. I just think it will be easier for you to view them and keep up with things this way. But anyway, to begin with, we will work through, I think, numbers 1 through 5. So number 1, write the y equals mx plus b form of the equation of the line passing through these points, negative 7, 3 and negative 2, 12. Now first, we need to know that for an equation of a line, we need two things. We need a point. Well, we've got two of them. You can choose either. And we need a slope. Well, we're not given a slope, but we can find it. We know that to find slope, we use the formula y2 minus y1 over x2 minus x1. So plugging in from our points, we will have negative 12 minus 3 over negative 2 minus negative 7, which gives us negative 15 up top. Now remember, this becomes a plus, minus the negative becomes a plus, and then negative 2 plus 7 gives us 5. So this is our slope. Now we're ready to write the equation of a line. So we can start by using this formula, plugging in either point. I'm going to choose this point. So we will have y minus y1, which is 3, equals m, and we just found it, it's negative 3, times x minus x1, which is negative 7. So again, this becomes a plus, and what we're going to do is distribute that negative 3 on the right. So we get y minus 3 equals negative 3x. That's a plus 7. So times the negative 3 gives us a minus 21. And then to get y completely by itself, add 3 on both sides. And so we get y equals negative 3x minus 18. Now, your exam is multiple choice. This practice exam is not. I just didn't have time to set it up that way. But when you're working your problems, just work and then choose your answer based on what you have found. All right, number 2, find the x and y intercepts of the graph, put answers in point form. Okay, so we need to remember to find an x-intercept, we let y be 0, and to find a y-intercept, we let x be 0. So for the x-intercept, we're looking for a point. We're plugging 0 in for y. So when we plug 0 in for y, that zeroes out. And when we solve for x, divide by negative 4 on both sides, and we get 6 for the x. For the y-intercept, we let x be 0. Sorry, I didn't mean to erase that. For the y-intercept, we let x be 0. So when we go to the equation and plug 0 in for x, that part zeroes out. And to get y by itself, divide both sides by 8. And so y is negative 3. So this is the x-intercept. This is the y-intercept. And those are, y'all, I don't know why this is changing modes on me. I'm so sorry. All right, so those are the intercepts that we are looking for. All right, moving on. Number 3, graph the line. Now, when we're graphing lines, the way we go about the problem kind of depends on how the equation is set up, okay? So, if an equation looks like ax plus by equals c, So the x and the y parts are on one side with a constant on the other. The quickest and easiest way to graph is by using x and y intercepts. If an equation has the form y equals mx plus b, so y is by itself equal to mx plus b, the quickest and easiest way to graph it is by using the y-intercept and then the slope to move to another point. So in number 3, it looks like the ax plus by equals c. The x and y parts are on one side with a constant on the other. So we can quickly find the x-intercept by plugging 0 in for y. Well, when we plug 0 in for y, the y term goes away, leaving us with 4x equals 12. Dividing both sides by 4, we get x equals 3. So our x-intercept is the point 3, 0. When we look for that y-intercept, we plug 0 in for x. Well, when we plug 0 in for x, the x term disappears, leaving us with negative 2y equals 12. Divide both sides by negative 2, and we get y equals negative 6. So the y-intercept is at the point 0, negative 6, and that's all we need to graph a line, 2 points, and then the line will pass through them. Number 4, it looks like y equals mx plus b. So, easy things to find are the y-intercept by plugging 0 in for x. The x term disappears when we plug in 0, and y is 2. And then our slope is that negative 3/5. It's the m sitting in front of the x. Now, when our slope is negative, we're either going to use that negative up top or in the bottom, but not both places at once. We have to have a starting point. That's our y-intercept. So 0, 2 is what we plot first. Then use the slope. Now, if we use this form, from our starting point, the negative 3 tells us to go down 3, which will put us here. And then the 5 tells us to go to the right 5. There's another point on the line. If you choose to put the negative in the bottom, then from our starting point, the positive 3 tells us to go up 3, which puts us here. And then the negative 5 tells us to go to the left 5. So we get this point. Either way you do it, you're getting a point on that line. And then we just draw the line that passes through those points. All right, on to number 5. Find the slope of the line that is perpendicular to the line 4x plus 3y equals 7. Now, first of all, what do we know about perpendicular lines? Well, perpendicular lines have negative reciprocal slopes. So if we can find the slope of the line we're given, we're in business. What we want to do is solve it for y. So first, subtract 4x on both sides. And so we get 3y equals negative 4x minus 7. Now divide everything by 3 to get y completely by itself. I need an x in there. So we get y equals negative 4/3 x minus 7/3. Now that the equation looks like y equals mx plus b, the number sitting in front of x is the slope for the line we're given. Since we're wanting slope for a perpendicular line, we want the opposite reciprocal or negative reciprocal. Well, the opposite of a negative will give us a positive, and when we take the reciprocal of that fraction, we will get 3/4. So the slope we are looking for a perpendicular line is the positive 3/4. Now, had the problem said, find slope of a parallel line, well, what do we know about parallel lines? They have the same slope. So if that's what we had been asked for, our parallel slope would be the -4/3, exactly the same as for the line that we were given. All right, this ends segment 1. I will stop the video here and pick up with the next group of problems.